Okay, so hopefully everyone found the stream okay, and found the class work tab. So in there you'll find your notes packages. Okay, so if you click on that, okay, you'll find the notes package. Okay, but it'll have your name on it. It's personalized to you. It's your Google Doc, right? That means that throughout the course of the semester, you might want to add stuff to it. It's entirely up to you, whichever way is most comfortable for you. If you want to print it out at home and then bring the paper in and write on the paper, I'm fine with that. If you want to have it on a tablet or a laptop or just on your phone, that's fine as well. But know that there'll be times where I'll say you need to add this to your notes. Okay, so you need to be able to, that file is yours. You can modify it through Google Docs. Even if all you have is your phone, you can do it through your phone. Okay, but that'll be your notes package. You'll be using that very, very often. Okay, then you have your workbook package. Okay, for each unit. For right now, obviously you'll only need the one for unit 1. Okay, if you want to save space, okay, you'll only need the one for unit 1 for right now. Okay, and then there's other important documents. Okay, is the document we're going to go over here right away, which is the course syllabus. Okay, so we'll be going through that. There's also a formula sheet. Okay, you're going to need that as well, right? The smart cart and graphing instructions you won't need till much later. So my recommendation is there's a few of these files you need to actually have stored on your phone. Make them available offline in Google Drive. Okay, because if the Wi-Fi craps out or something like that, then you don't have your notes package. Okay, so I would suggest having for sure the notes package and the workbook package for unit 1 available offline for now. If you are going to be printing the notes package and the workbook packages, print them in black and white. Because by the time you're done printing the notes package, you're going to need a new color cartridge or halfway through. Okay, it's like 60 pages, so don't burn a color cartridge on that. Okay, you can always look for the color pictures online, and the color's not really all that important for many of them. So just make sure you have that somewhere. Okay, if you're doing that, just print it in black and white. Okay, questions on where you can find everything? Then let's go through the day 1 stuff here. All right, so obviously it's a different day 1 than it has ever been. Okay, we've got all this other extra stuff to learn. Right? For this classroom, guys, when I'm teaching here at the front, as long as you're not talking to each other, you can have your masks off. Okay, if you turn around to talk to somebody, you got a mask up. If you're coming up to talk to me, you cross the green line, we both got a mask up. Okay, that's just going to be the protocol from here on out. Okay, we also have to clean our desks. Okay, when we come in, when we leave, that's why you got a bottle of our finest white this morning. Okay, so you just squirt that on the desk. Paper towels are in the paper towel dispenser there. Okay, so before you leave, make sure you do that because they just got done before you got here by my previous class. Okay, and then obviously sanitize your hands when you first come in. Okay, for right now, that'll either be me holding the spray bottle. Okay, or you can use this big pump here because, unfortunately, there's nothing in those yet. Okay, our supplier dropped the ball and didn't get that stuff here quickly. So, okay, we got spray bottles and the pump thing over there instead. Okay. All right. So, attendance. Okay, most important thing. That's going to work differently this year. Hopefully, not too differently. Okay, but should you end up having to stay home, okay, if you have to self-isolate or quarantine or whatever, okay, you're going to need to follow along. Right? I'm going to make that really easy with Google Classroom and YouTube and all that. I'll make it super easy for you to follow along and not get behind. Okay, we'll talk about that in a minute. But obviously, attending school is the first and most important thing you can do for your success. The more you're here, the better off you're going to be. Okay. If you are absent, if you're at home because you're self-isolating or you're just not feeling well some other way, whatever, you're not here, you're responsible for what you miss. Okay, you got to make sure you use Google Classroom because every day I will post what we did. Okay, and that'll be a link to a YouTube video, which is what I'm making right now. Okay, because I'm recording everything I say and everything that's on the smartboard right now. Okay, that's what this thing here is. Okay, that's my microphone. All right, so it's going to pick me up mostly, okay, but it usually will pick up people's questions if you ask one as well. Okay, so I record that and then I post it on YouTube, usually as quickly after class as I can. So if you're at home, okay, by lunch, okay, it'll be posted and you'll be able to watch what we did that day. And if you're at home because you're sick, well, then sleep in, okay, and then get up and watch what we did. right? And in there I'll tell you, what worksheet packet or what worksheet pages we did. Okay, if we did a lab, I'll include a video of the lab, I'll include the data, okay, all of that kind of stuff. So if you're not here, okay, you can still do it from home, okay, if you're having to quarantine or anything like that, okay? Okay, for lates, make sure you're on time, okay, obviously with all this, new traffic triangle stuff that we're doing, okay, it takes you a little longer to get everywhere, okay, just do your best to get here on time. I can't close the door anymore. Okay, so if you're late, just wait outside and I'll let you in when it's not an interruption. Okay, but let's try and be on time as much as we can. Okay, so the resources you have available to you. Okay, obviously Google Classroom is kind of your one-stop. Okay, for catching everything. Okay, you just want to go into the stream. Okay, and each and every day I will be posting. Okay, what we do, okay, and it'll look something like this. If there's files you need, they'll be posted in there. There'll be a link to the YouTube video, okay, all of that kind of stuff, it'll all be in there, okay. If you want to just go to the YouTube channel and see what's there, that's fine too, okay. It's CoderreScience, you can subscribe to it if you want.
Hello again, everyone.
Or not.
Please allow me to interrupt.
All right, so back to this here. As Mrs. O was saying, for lunch, okay, the new regulations are you have to eat on a flat surface, which is why you can't eat in the stairwell. You have to have something that you can clean before you eat and something you can clean after you eat. I don't make them up. I just tell you what they are and you have to follow. Okay. All right. So obviously we talked about Google Classroom and we talked about the YouTube channel. Okay, it's CoderreScience. If you want to access that or whatever, okay, you can subscribe to it or not. I don't make a cent off of that channel. Well, I only have 500 subscribers. You have to have 1,000 plus. I don't care. Okay. When it was monetized back before the 1,000 thing, I think I made a quarter off of it in like 5 years. So, you can watch it as much as you want or as little as you want. It's like, no, never mind to me. Okay, but it's there for you to use. Okay, and obviously for physics, okay, there'll be a playlist here or several playlists under Physics 20 lessons. They have all the ones from last semester still there so that you could see them. Okay, but I'm going to be taking those off, and obviously each day as I record a new one, it'll plug right in there. Okay, and you'll be able to watch them to review, or if you're not here as your actual class, okay, that's how that will work if you have to be at home for a while. Now, if you do have to be at home for a while because you're self-isolating or whatever, okay, you're not on your own, okay? If you are watching those videos and you have questions, then send me an email, okay? I will answer it, okay, as long as it's not coming in the middle of the night, right? Because people were doing that during the quarantine. Getting emails at 2 in the morning. Joke was on them. I get up at 5. Guess when I answer emails. I'm sure they were still awake at 5. Yeah. So, yeah, don't email me then, okay? Because I won't answer you, and I'll answer you much earlier. So, yeah. Okay. But yeah, email me if you have questions, okay? Or even over lunchtime, you can call the school, and I'm going to be in my room here, okay? Because people will be eating in here. They can even put you through to my classroom, okay? And I can talk to you on the phone. It's over lunch. Okay, but if you've got questions, you're not on your own, email me and I will help you. Okay, hopefully that's not going to be something we're going to have to encounter too often, but I imagine it's going to come up a couple of times here and there. Okay, all right, so those are the resources that are there for you. Okay, just make sure you stay caught up as best you can. Now, obviously, if you have to stay home because you actually have COVID and you're like really, really, really sick, I'm not going to be expecting that you're going to stay caught up. Because if you're running a fever where you're delirious, you're probably not going to take in very much. Okay, if that's the case, obviously I'm going to be pretty forgiving on things like due dates, and I'll help you get caught up when you're done. Okay, but if you're just home because oh, I had a sore throat one day and I have to stay home because technically that's what I have to do now, you're not really sick. I expect you to stay caught up. Okay, all right. Any questions on that stuff? So for classroom behavior, okay, obviously respect is really important. That's the key here. Mrs. O talked about that in period 1. Okay, it's an environment where everyone should feel safe, included, and welcome. Okay, I'll show you respect. I expect the same in return, and the same for your classmates. Okay, so I'm not going to call you out and humiliate you in front of the entire class ever. Okay, that's not what I would do. Okay, I don't expect you wouldn't do that to somebody else, okay, in the classroom either. My cue for getting your attention is listen up. So if I say listen up, I need earbuds out, both eyes up front here, because I'm starting something, I'm about to tell you something really important, the room will be on fire and you have to leave, whatever. Okay, but if I say listen up, I need your full and undivided attention at the front. Okay. There's different kinds of work, okay, in physics. Okay, there's kind of the learning work that we'll do in class. So if I just taught you v equals d over t, and we're working on a couple of practice questions from the workbook. Okay, that's work that isn't going to get taken in or checked. Okay, it's worksheets, it's from the workbook, the answers are in there. Okay, I'm not going to be coming around to check whether you did it or not. It's there for you to work on while I'm here to help you. Okay, or for you to practice it at home and ask questions or whatever. That's what it's for, but it won't come in for marks. Okay, the kind of stuff that does come in for marks would be lab reports, assignments, research projects, things like that. Those things will be coming in for marks. They'll come in through Google Classroom, right? Those ones, obviously, you need to get done. Okay, the classroom stuff that we're just working on for practice, that's up to you. If you're feeling pretty proficient at it after doing 5 or 6 questions and there's 10 on the sheet, then maybe you don't need to do all 10. Okay, you're mature enough to make that decision for yourself. Okay, if you want to go home and do all 10 for extra practice, good on you. All right, if you're really struggling with it, you've done all 10, you're still struggling with it, then come in and ask for help, and I can probably find you a few more. Right, but that part is up to you, and that part is not coming in for marks. Okay. All right, all of it, okay, the stuff especially that's coming in for marks should be completed. I never just give you work so that you have to sit at your desk and I can go on social media, because I don't do that when I work. Okay, that's not what I do. Okay, if I assign you work, that means you're practicing it. Okay, I'm doing some work at my desk, or I'm circulating and helping you out and answering your questions. Okay, also, in terms of exams, should you by some act of God achieve a mark of less than 50% on an exam, and that is very rare, okay, I will have you come in and work on some kind of makeup work, and then after that I will adjust the mark slightly, okay? It's not a rewrite. We don't do rewrites in physics, okay, just so you know, right? I'll give you 2 weeks notice for a unit exam. That's plenty of time to get prepared and come in and talk to me and get help and all that kind of good stuff. Okay, but if you choose to roll the dice and go, I'll just study for 5 minutes before class starts that day, that's a bad choice. Okay, make sure you get well prepared, because there won't be a rewrite. Okay. Fairness or equality. Okay, I always try to be fair to everybody, but that doesn't always mean that everyone gets treated exactly the same, because everybody has different circumstances and things going on in their life. Okay, so I will do my best to be fair to everybody. If you ever feel I haven't been fair, okay, then please come and talk to me about it after class. Okay, the example I always use happened about 12 years ago or so. The class was handing in their stuff back when we handed it in on paper, and I had 2 people at my desk who didn't have theirs done. And the first guy standing there, and I was like, why don't you have it done? Well, I was binge watching this show on TV last night, and I fell asleep on the couch, and I didn't get done. You had 2 weeks to do that. What the hell? Like, you might as well leave it till the last minute. At least he was honest with me, to his credit. He told me exactly why I didn't have it done. Okay, he had to take a late penalty. I still accepted it, but he got docked late marks and got it in. Okay, the person standing behind him looked like she would have to get better to die. She looked terrible. Like, if you can imagine what somebody really looks like when they're actually green, she looked green. Okay? It was awful. And she's kind of like swaying. She wasn't. And I'm like, are you okay? No. I'm not feeling very good. Pretty cautious. And I'm like, okay, can you back up a couple steps in case you like puke? I don't want to get puked on. It's really traumatic. And it's like, well, what's going on? I said, well, I don't have my assignment done. Not. Well, last night my parents got in this huge fight, and they both stormed out of the house, and then I had to make dinner for my brother and my sister, and I cooked frozen chicken, but I didn't cook it enough, and they all got really, really sick, and I don't have my work done. Like, all right, well, that really sucks. And then because I'm a teacher and about this much of a jerk, okay, I was like, if you hadn't left it till the last minute, that wouldn't have happened. Just so you guys know, calamity always strikes when you are least prepared to deal with it, and that would be that.
Well, my so-called engineer.
Oh, yeah, just they all have their names on it. So in the end, I felt bad for her. Circumstances were a bit beyond her control. I gave her a 1-day extension. She got it done. She never did. Okay, I didn't treat them the same, but their circumstances were different. Okay, so if you ever feel I haven't been fair, come and see me about it after class. Okay, and we can talk it over. All right, accountability, okay? You have to be accountable for, okay, due dates and things of that nature, okay? Getting stuff done on time, okay? All of that, okay? You're 16, 17 years old, okay? So you guys can be accountable for that stuff. So make sure you get all of your assignments handed in on time. I give plenty of time for assignments to get completed, okay? The shortest turnaround you will ever have for an assignment in my class is 2 school days. All right, so if we did a lab on Monday, the earliest it would be due would be Thursday. Okay? And most of the time, those 2 school days also involve a weekend. Right? So you get the extra couple of days. I can't remember the last time I made something due 2 school days later. It's usually 3 or 4 plus a weekend. Okay? I give plenty of time for you to get stuff done because I want to help you with your time management skills. Doing a lab and then saying, okay, go home and do 6 hours of work tonight. Not that the lab would take you that long, but go home and do a bunch of work and it's due tomorrow. That's not fair to you. Okay? That doesn't help you learn time management. It makes you learn how to deal with stress. Maybe not in a good way, okay? But that's not what we're about. It's not what I'm about. So you're not going to ever have a turnaround that quick in my class. Okay? I'm never going to ask for something the next day. Okay, but that means obviously then that I have pretty high expectations on that you're going to have it done when it's actually due. Okay, so assessment and evaluation. Okay, first thing is I will not discuss your mark with you in class. Okay, if you get something back and you're not happy with the mark, okay, you don't come up to me in front of the entire class and talk it over because I won't. Okay, I can't do that in front of everybody else. Okay, it's a FOIA thing, okay, and it never ends well. So if you have a question about your mark, then come and see me at lunch or after school or something like that. Okay, I'll be happy to talk to you about it then. Okay, when we don't both have to save face in front of everybody else. Okay. Your marks will be distributed according to the syllabus. We'll talk about the weightings here in a minute. Okay, assignments and labs, anything you're handing in is to be handed in on time. Late assignments can be handed in, but they will be penalized 30%. Okay, if you know you're going to be absent on a due date, okay, well, everything's coming in through Google Classroom, so submit it electronically from home or wherever you are. Okay, I once had a kid who went on a student exchange to Belgium. He took my class virtually for 4 months. He never had a late assignment, and he was in a different time zone. Okay, so it's entirely possible to do it that way. Okay, there's really no reason for you to not be able to get it done unless you're running a really high fever and not getting things done. Okay, so just know that that will happen. The other reason why late penalty is so high is this: you will always get your assignments back from me the next day. I have only failed to do that once in 22 years of teaching, and it was the day my second son was born. I stand by my decision to hold my wife's hand while she gave birth to my son than to sit there with a stack of labs and mark. It was the right decision, and I stand by that decision. Okay, I got them back the day after. Right? But yeah, guys, that's the right decision that ever comes up for you. So they will come back to you the next day, okay? And that's why the late penalty is so high, because it doesn't do much for me to, electronically hand them back to you a few hours after you hand them in, and then somebody else can just copy it, okay? And there's a lot of that goes on, so that's why the late penalty is so high. It's either in at the start of class, or you're going to take the 30% late penalty, okay? Unless there's really extenuating circumstances. All right. All assignments and labs are due at the start of class on the due date. Okay, I know every teacher has a different rule about this. Some people like, oh, it's the end of the day or it's midnight. Okay, for me to be perfectly fair to all my classes, if I make it due at the start of class, every class gets exactly the same amount of hours to do the job. Okay, otherwise the morning class gets a 6-hour advantage over the afternoon class in getting something done. That's not fair. So it's due at the start of class on the due date. Okay, make sure you haven't done that. I usually remind people because if something's due, I check Google Classroom to see how many people have handed it in. If yours is missing, I'm usually like, hey, did you just forget to click turn in? Like, I need that right now. Okay, so I'll give you that little reminder. Okay, I don't know why that copied twice, but it's there twice. Okay, so for the new map, obviously you guys kind of walked through that already once. Okay, so we got the traffic triangle thing going on now. Hopefully you're going to get that figured out. It's nice that there's not too many people in the school today. We did that half and half thing so we can get that figured out before it's really busy. Okay, just remember when you leave my class you have to walk all the way up the end of the science wing. Okay, and then you can decide which door is better, to go in over by the gym or to go in through the theater. Okay, either one of those is probably your best entrance. Okay, but remember, it's one-way traffic through the atrium. All right, so if you come in through the theater, you have to go around, right? And then the two up stairwells, okay, the one here back by the computer labs and the one over by the wood shop, okay, those are the two up stairwells, and the one closest to us here is the down stairwell. Okay? That's just the only thing to keep in mind for upstairs, because obviously traffic flow upstairs is also one way. Okay, so if you have a class in this wing here, okay, which is mostly English, then you need to come up the stairs by the wood shop, okay, in order to access those classrooms. Coming up these stairs will not give you access to those classrooms. Okay, I know it's really inconvenient, but that's what we got to do. Okay, and then we had that stuff. All right. Okay, any questions on any of that? Closest bathrooms, okay, Mrs. O talked about that in period 1. Okay, the closest girls' washroom is basically right outside the door here, okay, and the boys' bathroom is just a little bit further down the hall. Okay, that way, obviously, during class, you do not need to walk all the way outside to get to the bathroom. You can shortcut, okay, it's just a break. And obviously, because the capacity on those is now only 2 people, of course, it kind of always was, because there's really only 2 stalls in each one, but they tended to be way more than that in there. Take 2 in there at a time. Break is probably not the best time to try and use the washroom. So if you need to go during class, just ask. It's not a problem. Okay. All right, so for our course syllabus, there's 4 units. Okay, in Physics 20, the first unit is Kinematics, and a lot of kinematics will hopefully seem familiar from Science 10. We're going to go over things like V equals d over t, we'll go over position versus time, velocity versus time graphs, acceleration, but we'll add a bit to acceleration, a few new formulas there. We'll be talking about vectors. Okay, vectors is a big part of Unit 1 and Unit 2. There'll be a fair amount of trigonometry involved in that. Okay, so SOHCAHTOA and all that kind of good stuff. Okay, we'll be going over that. So that's vector addition, and then the end of the unit is projectile motion, which kind of combines everything together. Okay, that unit will take us up to beginning of October. Okay, Thanksgiving or somewhere in there. Okay, so that'll be the first unit, and then the second unit is dynamics. And in dynamics, we look at the same kinds of motion that we looked at in Unit 1, but in Unit 2, we look at the forces that cause them. Okay, so rather than just looking at the motions themselves, this thing's accelerating, this thing traveling at a constant velocity. In Unit 2, we talk about what's making it do that. Why is this one accelerating? Why is this one only moving at a constant velocity? So we go over Newton's laws, first, second, and third. Okay, and then we go into some stuff that's hopefully familiar from Science 10. That's work energy theorem and law of conservation of energy. Okay, so those were in Science 10. That will take us up to around Remembrance Day, middle of November, somewhere in there. Okay, and then Unit 3 is circular motion and gravitation. Okay, that one tends to be a bit shorter. It's probably the shortest of the 3 units. Okay, we look at why things move in a circle, why planets orbit the sun. Okay, we look at vertical and horizontal types of circular motion. That unit will take us to about start of December. Usually about 3 weeks, okay? And then after that, we have simple harmonic motion and mechanical waves, okay, where we look at things that oscillate, okay, and how waves travel and different types of waves and things like that. And that will take us up until the second week of January, and then you'll have your final exams after that. Okay, so questions on what will be in the course? Okay, so for assessment, okay, your unit exams and your final exam are a huge portion of your mark here. Okay, reason being is those are the assessments that we know tell us what you know. Right? Prior to the pandemic and during the isolation quarantine stuff, we discovered just how much copying really goes on, and so we kind of changed how much of your mark is dependent on things that can be copied. Okay? So your labs, assignments, and projects are 20% of your final mark. Your quizzes, which I haven't talked about yet, are 10% of your final mark, and your final exam is 25%. Your unit exams are 45. Okay, so I was at 10 and a bit for each one. Okay. All right. Quizzes. In my class, you will have a quiz on Tuesday and a quiz on Thursday every week, unless you're told otherwise. You don't have one tomorrow. You won't be here. Okay? But otherwise, every Tuesday, every Thursday, you're going to have a very short quiz. We usually have 2 questions that are on the stuff that we've been going over in class. Okay? Now, I make these pretty easy, and this is how I make them easy. On Monday after school and on Wednesday after school, I will post a practice quiz, which is basically so much like the quiz you're going to do the next day, like it's basically the same. Okay? So what you do that night is you go home and you try it, you take 10 or 15 minutes, you try it yourself, talk to your friends, okay, see what they did, talk it over, get it figured out, okay, that's all part of the learning process, that's not cheating, okay. I gave you a practice quiz because I wanted you to figure out how to do it. You come in the next day and I give you a quiz that's very much like that one, and you do really well on it and handed it, okay. So that's kind of how I do homework checks, is doing quizzes, okay, you do well on those. They're pretty easy, there's really no reason to not do well. If you don't do well on one, it's also not a huge deal, okay. You're going to have 2 a week and they only add up to 10%, okay. Now, you don't want to crap the bed on every single one because that adds up to 10%, but okay, if you do well on all of them, that's an easy 10% to get. Okay. All right. Questions on any of that stuff, guys? Okay. Is it okay to have food and drink in here? Yes, it is. Just make sure that you clean up any mess you make, okay? And obviously you've got a flat surface there; it just needs to be cleaned before and after. So that's fine. You want to coffee or you want to eat your lunch early or whatever. I'm fine with that. Okay, just make sure your hands are clean before you do so. Can you listen to music in here? Yes, you can in certain situations. Okay, if you want to have your earbuds in while we're doing seat work, that's fine. But if I'm teaching like I'm right now, then no. Okay, you have to have your can't have your earbuds in for that. Okay, but you can during the other times. I can't think of anything else. Okay, any questions from you guys? Something comes up, don't be afraid to ask later. Okay. Yeah. Okay, let's move on to our first lesson then. So, if you can take out your phones, okay, and call up the notes package. Okay, we're going to get going on lesson 1 here. Okay, let's do that. Okay, so anytime, guys, that we're doing a lesson where I'm teaching you something new, okay, this is what it'll look like. The title slide will have the lesson number, which will correspond to the lesson number in your notes package. Okay, so this is Unit 1, Lesson 1. Okay, and then there'll be key points. Okay, the key points are there so that when you're coming back to study, you know, for a unit exam, final exam, whatever, you know what the really important stuff is in this unit, and you don't, or in this lesson, you don't necessarily need to read the whole thing. Okay, save you a little bit of time. Okay, so the key points for today, okay, understand that the motion of objects and systems can be described in terms of displacement, time, and velocity. That is this thing that you are probably familiar with. Okay, V equals D over T. Okay, so V equals D over T, hopefully you're familiar with that. Obviously there's 2 different versions of that formula. Okay, there's this version, which deals with scalar quantities. That would be speed, distance, and time. Okay, and there's this version of that formula, okay, which deals with vector quantities, which are velocity, displacement, and time. Okay, so hopefully that's familiar from last year. Okay. Define operationally, compare, contrast scalar and vector quantities. So we just need to remember, that's review from last year, scalar quantities have a magnitude only, okay, while vector quantities have both magnitude and direction. Right? So speed would be 100 kilometers per hour. Okay? Velocity would be 100 kilometers per hour north, okay, or something like that. Right, and then defining velocity as a change in position during a time interval. Okay, this is the mathematical way to write that. Okay, velocity is the change in position. Okay, because that's what displacement is. So we would have like final position minus initial position over time. Okay, that's V equals D over T. Change in position over change in time. All right, is that ringing a bell? Okay, if you took Science 10 during second semester last year, that may not be as familiar as if you took it first semester. Okay. All right, so big thing here, guys, is we have to realize that in North America, the way we talk about distance is really messed up. Okay, we do not describe distances correctly. Okay, as an example, if I was to ask any of you how far it is to Edmonton, how many of you right now are thinking it's 3 hours? Almost to a minute, but that's what you would tell somebody. Okay, if they ask you, how long does it take to get somewhere? How far is it to there? You tell them how long it takes. Okay, we almost never tell them what they ask for. Okay, how far is it, Devin? 3 hours. How far is it to Calgary? Half hour. Okay, we never tell them how many kilometers, even though that's technically what they asked for. Okay, because technically we knew they didn't want that. They wanted to know how long it would take, even though they asked us how far it was. Okay, so we have to kind of break that habit a little bit, okay, in physics. When a question says how far is it, it wants to know how many meters, kilometers, centimeters, okay, whatever it is. It wants the actual distance, right? Not how long it would take. Okay? If it asks how long it would take, it's looking for time. Right? So if you've ever gone hiking off trail, done any orienteering, okay, you know that the way we describe travel in everyday life is really only effective at getting you hopelessly lost, okay, in a roadless or trackless environment. Okay? Because we might say Calgary's 40 kilometers away. Okay? Well, that's effective for all of us because we know where Calgary is. Okay? It's easy for us to just get on the road and get there. Right? But if I am completely unfamiliar with this area and you tell me Calgary's 40 kilometers from here, I might not get there. Okay? Especially if I don't read or speak the language, I can't read the road signs, I'm pretty cooked on that. Okay? I don't need to, I have no way to figure out where it is. And it's worse if you're in an area where there's no roads, tracks, or signs. Okay? If you're out in the middle of the ocean and you're trying to get to Barcelona, okay, like how many different choices do you have for which direction to go? 360. Okay, what are your chances of getting to Barcelona if you're in the middle of the ocean? If you're in the middle of the Pacific, practically none because you're in the long ocean. Okay, yeah, it would be pretty tough because nobody told you which way to go. Okay. All right, so does that sort of make sense? Okay, in terms of that, like, but it can be pretty inconvenient. Okay, I know I had a time when I was backpacking, and I've been backpacking all day, hot day. We'd gone like 30-some kilometers, and we weren't where we were supposed to be yet. And we encountered this guy who was wearing like fatigues, army fatigues, big giant pack, and he was practically running up the hill towards us. And we're like, oh, sweet, this guy will be able to tell us where the campground is. And so we stopped him and we're like, hey, can you tell us where Tumbling Creek campground is? Like, how far is it? He's like, oh yeah, it's like 20 minutes. 20 minutes down the trail. I'm like, oh, sweet. Only 20 minutes. It was like an hour later, okay, that we got there. And we were cursing this guy, okay? And then we thought about it once we stopped, had some water and some food and whatever, and started thinking clearly again. Okay, we're like, the guy was probably like a Navy SEAL out for a jog with his pack on, right? He's running up the hill at us. We're stumbling around downhill because we're so tired. Okay? Of course it took us way longer to get there than it took him, but he told us it only took him 20 minutes to get that far. Okay? Because he was in really good shape and we were a couple of teachers on summer vacation. Okay? We were out of shape and tired. And so, telling us how long it took him was not an effective way to tell us how far it was to the campground. If he had told us it was 3 kilometers, we didn't know we were in for an hour's walk. All right, so we got to be careful about how we describe things and whether it's an appropriate time to use a scalar description or an appropriate time to use a vector description. Okay. Another example could be if you get pulled over by the police and they ask you how fast you're going. Okay. Do they want a vector description or do they want a scalar description? Okay. Picture this: you've pulled me over. You come up and go, you know how fast you were going? And I go, yeah, I was going 127 kilometers an hour at 15 degrees west of south. You're going to have a follow-up question for me. You had anything to drink today? Right? Because that's a weird way to answer that question. He wasn't expecting a direction on that. He just wanted to know how fast I was going. He wanted a scalar description. He wanted my speed, 127. Okay? That's one of those times where say as little as you need to. Okay? Saying too much gets you in more trouble. Right? Okay, so scalar descriptions are appropriate sometimes, and other times they're not. Okay, if we were, even in the school, if somebody asked me how to get to a different classroom, okay, I wouldn't just say it's 10 meters from here. Okay, that's not very helpful. It's 10 meters north from here, or 10 meters down that hallway, or whatever. Okay. All right, so a more descriptive description than scalar is to give someone a vector description. It isn't more accurate. Okay, people get this idea that vector quantities are more accurate because they also contain a direction. Okay, they're not. Accuracy depends on your measurement, not on whether you also add on a direction. Okay, so if I say Calgary is 40 kilometers away on a vector of 13 degrees west of north, that's just as accurate as my scalar description of 40 kilometers. It's 40 kilometers plus or minus 1 kilometer. Okay, I've just added in that this is the direction you should go. Okay, it's more descriptive. It has additional information. It isn't more accurate. Okay, so this is a vector description. Okay, it not only tells us where Calgary is, but also how to get there by telling us in what direction to head. Okay, vectors are not always measured in degrees. Okay, they can be as simple as positive and negative, which is what you would have dealt with in Science 10, forward, backward, right, left. Okay, but in Physics 20, okay, we deal with compass directions, so it becomes more accurate. Okay. All right. Okay, so when we give the distance an object travels, we give a scalar quantity. Okay, so distance is scalar. It's 100 kilometers, okay, or 100 kilometers per hour. Okay, those are scalar descriptions because they have no direction. Okay, displacement, okay, is going to be the straight line change of position from where I started to where I ended. All right, so the example I'm going to use here is a trip from my house to Walmart. Okay, so if I'm going from my house to Walmart, I can't go there in a straight line unless I own a helicopter. If I own a helicopter, I ain't shopping at Walmart. Okay? If I can afford a helicopter, I can shop nicer places than Walmart. Okay, so I have to follow the road. Okay, well the road doesn't go in a straight line. Okay, so I've got to follow the road out of my neighborhood, and I've got to go across the river on the bridge, and then I've got to make some turns and follow Southridge Drive and whatever else, and finally get there. Okay. When I get there, okay, the distance I have traveled is represented by this black squiggly line. It's how far I actually had to go to get there. Okay? That can't have a direction because I changed directions a whole bunch of times along that black line. Is everybody okay with that? Okay. The pink line, or the purple line here, okay, represents my displacement. It is my change in position from my house to Walmart. Okay, so your displacement is always the shortest straight line distance between 2 points. Okay, and it does have a direction because it's a straight line. Okay, there's only one direction that I went here. Everybody okay with that idea? All right. So, so let's say that when I went to Walmart, okay, I followed this path here, okay, and let's say it was 4 kilometers. Okay, when I got to Walmart, I had traveled 4 kilometers. Okay, but I actually only ended up 2.8 kilometers in a straight line from my house. Okay, 2.8 kilometers, 38 degrees north of west. Now, where do I get that measurement from? Well, if I have a compass on here, okay, I'm going this direction, right? According to the purple line. Okay, so this is due west. This is 38 degrees north of west. Okay, I don't just say northwest because 38 degrees northwest could be this line or that line. That would be west of north. They're not the same direction. Okay. Everybody all right with that? Okay. Like northwest would be like 45 degrees because then it's equal from both. All right, so I've got that. Okay, that's my displacement. This is my distance. All right, now we learned these two formulas last year. V equals d over t and v equals d over t. Okay? If I want to calculate my speed, I need both the distance and the time. All right? I already know the distance. Okay? It's 4 kilometers. Well, let's say it takes me a half an hour to get to Walmart. Okay? What's my speed? 4 kilometers to Walmart, took me half an hour.
70, 50 meters.
No, let's just keep it in kilometers per hour. Okay, so I'm 4 kilometers in a half an hour. How far have I gone in an hour? Not 2, 8, right? Took me half an hour to walk 4 kilometers, okay? It would take me an hour to walk 8, right? So is my speed 8 kilometers per hour? Okay, here's how I figured that out, guys. I went speed equals distance, 4 kilometers, divided by 0.5 hours. 4 divided by 0.5 is 8. Okay, so my speed is 8 kilometers per hour. That's how fast I walked to get to Walmart. 8 kilometers per hour. Okay. All right, what's my velocity? Well, velocity is displacement divided by time. Okay, my displacement is 2.8 kilometers, 38 degrees north of west. Okay, is my time still a half an hour? Time's the same, right? This is how much I ended up displacing myself, but it still took me a half an hour to do that. Okay, so I would say my velocity is 2.8 kilometers at 38 degrees north of west divided by 0.5 hours. Okay, so now my speed, or my velocity is 5.6 kilometers per hour at 38 degrees north of west. Why didn't my direction change? Why did I keep that? Still going to the same place, right? Yeah, I followed that path. My velocity has to always be in the same direction as my displacement. It is not possible for me to displace myself north while traveling east. Okay, it's just not possible. Okay, so your velocity and your displacement are always going to have the same vector. All right, everybody with me so far? Okay, this is just a V equals D over T type of question like you would have done in Science 10. Okay. Now, because I'm getting old, my mind is failing. Okay, I get to Walmart and I realize I don't have my wallet. I'm not going into Walmart for fun, so I turn around and walk back to my house along exactly the same path at exactly the same rate. Half an hour later, I'm back at my house. How far have I gone? Eight kilometers. Yep. Okay. I traveled to Walmart. It was 4 kilometers. It was 4 kilometers back. I went 8 kilometers. Took me 1 hour. What's my speed? 8 kilometers per hour. Right. I got there. I turned around and went right back. Okay. So 8 kilometers per hour. What's my displacement now that I'm back home? I started at home, went to Walmart, came back home. Remember, displacement is my change in position. It's 0. Yeah, I haven't changed my position. I may have walked all the way to Walmart, but I'm back where I started. Okay, which means my displacement is now 0. Okay, because my final position and my initial position are the same place. Which now then means my velocity for the whole trip is think about the formula. Velocity is displacement divided by time. You just told me my displacement is 0. So what's my velocity? 0. Yeah. 0 divided by anything. Right. I didn't go anywhere. From a vector perspective, I ended up back where I started. I didn't go anywhere. Okay? Can't have a velocity if I don't have a displacement. There was no trick. There was nothing. Okay? This is exactly why the odometer in your car measures distance. It would be totally useless if it measured displacement. What would it always read when you get home? No, it would read how far it is from the dealership you bought it at to your house. Everybody answers 0 when you get home. Yeah, but it's not. Okay. Yeah. So it would be totally useless. You could, when it came time to sell your car, it could have 1,000,000 kilometers on it, but it would read 3.5. Right? Because you always came back to where you started. Okay? That would be very useful. Well, it'd be great for you as the seller, but terrible for the buyer. All right, so getting a review here of scalar versus vector. Okay. Okay, so looking at a typical map, right? If I am here at Seldom Inn Campground, that's what that's called, and I want to go to here, at Snake Indian Falls Campground, okay, there's a sign right here on the path. Is it gonna, what's it gonna tell me in terms of information about getting to here? Is it gonna give me a displacement or a distance? Distance. Okay. Why is a scalar quantity better here than vector? What does that sign assume I'm going to do? Take the path. Yeah, exactly. It means the sign is going to assume I'm going to do this because this is the most logical way to get from A to B. So it's going to tell me that it's 28 kilometers to Snake Indian Falls Campground from here. Okay? It is not going to say that it is 19.7 kilometers at 29 degrees north of west, because that's crazy. Okay? This shaded part is a glacier. Okay? There's like rivers and stuff. Like at least on the path, when you cross a river, there'll be what? There'll be a bridge, right? This is all bushwhacking and all manner of disaster. Okay, to go along that path. It'd be great if I had a helicopter, but hey, I don't. The sign is not going to give me, in this case, a vector description. There are times when a scalar description is better. Okay? And there's some things that are only measured in a scalar fashion. Okay? Mass is an example. Right? My mass is 78 kilograms. I don't give a direction on that. There isn't one. That's just how much of me there is. Okay? There's no vector on that. Okay? If someone asks you how much you weigh, that actually is a vector quantity, believe it or not. Because weight and mass are different. Okay? Mass is how much of you there is. Weight is how hard gravity pulls on all of that. Okay? So when somebody stands on you, okay, you don't feel their mass. You actually feel their weight, which is a downward force acting on the body. Okay? Do this at a party next time somebody asks you that very rude question. Okay? If somebody asks you how much you weigh, tell them. Okay? It'll be in newtons. Take your mass, multiply it by 9.81. Okay? So for me, it's going to be like, what, 750 newtons down. They'll go, and they'll walk away. Okay? And you didn't lie. Okay? You didn't lie about your weight. You told them what their weight was. They have no idea how many newtons anything is. Okay? And they think you're weird, and they'll leave you alone and not ask you that rude question. Get out of it a lot of different ways. Okay, so does everyone kind of follow here? Scalar's good sometimes, vector's good sometimes. There's not really one being superior to another. Okay, they both have equal applicability in different situations. Okay, so speed and velocity have a similar relationship. They both measure how fast you're going. Okay, one measures it though just from that perspective. This is how fast you're going. How much distance you cover in a specific time frame, okay, kilometers per hour or whatever, okay? Whereas velocity tells you how much or how quickly you are changing your position and in what direction you're doing that, okay? So it also has that vector part, that direction on it, okay? And then obviously distance and displacement are similar. Distance tells you how far you've gone, but displacement tells you how much and in what direction you've changed your position. Okay, so they're very similar. They both measure, for distance and displacement, how far, okay, but they do it from different perspectives or different points of view. Okay, and we already talked about that part. So, okay, this is just terminology. It's in your notes package, so you don't necessarily need to write it down, and it's review as well. Okay, scalar quantity, any measured quantity that has only a magnitude, 40 kilometers. Okay, distance is a scalar quantity that measures how far an object has traveled. Speed is a scalar quantity that measures how far an object travels in a set time interval. Okay, vector quantities are measured quantities that have both value and direction. 40 kilometers forward, 3.2 kilometers, 18 degrees west of south. Okay, so magnitude and direction. Displacement, vector quantity that measures how far and in what direction an object has traveled from its, it's a typo, its starting position. Okay, and then velocity, vector quantity that measures the displacement of an object during a set time interval. Okay, and then our formulas are obviously v equals d over t, speed is distance over time, and velocity is displacement over time, which we can also write expanded out to look like this. Final position minus initial position over time. Okay, because because that's what displacement is. Displacement is your change in position. Okay, so hopefully that all feels somewhat familiar to you, okay, from Science 10. Okay, so let's look at this example here. So let's say I've got this traveler who's standing 1.5 meters to the right of an Inukshuk. Okay, they move so that they are 3.5 meters to the left. So this is their initial position, and this is their final position. Okay? What's their displacement? Okay, so displacement is final position minus initial position. Okay? They end up left of the Inukshuk, but they started right of it. Are left and right opposites? How do I represent that mathematically?
Negative and positive.
Negative and positive. Okay, so I'm going to make left negative and right positive. So that means my final position is negative 3.5 meters minus my initial position, which is positive 1.5 meters. Okay, well, what's negative 3.5 minus positive 1.5? If I subtract a positive, don't I get more negative? Right? Okay. So negative 3.5 minus 1.5 is, okay, what direction did negative represent? Left. Okay, so my displacement here is 5.0 meters left. Well, that's exactly what they did. They started here, where they were 1.5 meters to the right of this thing. To go all the way over here, they went 1.5 plus 3.5. They went 5 meters. 5 meters to the left. Okay, are we all right with that idea? Okay, so that's okay, how we kind of represent that from a vector perspective. Okay. All right, I want you guys to try those. The answers are on there. Okay, I want you to give them a try. Okay, so sprinting drills include running 40 meters north, walking 20 meters north, then sprinting 100 meters north. Okay, I want you to calculate the sprinter's displacement from the initial position. I think you'll find that one quite easy. I think you'll find all three of them quite easy, in fact. Okay, so I'm going to give you a couple of minutes here, and then we'll go over the answers. Okay. So for number one here, okay, we got 40 meters north, 20 meters north, 100 meters north. What do we do with those three numbers? We just add them up. They're all the same direction. Okay, so the displacement of that sprinter is going to be 160 meters north. Yeah, simple as that. Okay, for question number two, to perform a give and go, the basketball player fakes out the defense by moving 0.75 meters to the right and then 3.5 meters to the left. So I'm going to draw a diagram of this just to make it easier for me. Okay, so I'm going to say, here's my 0.75 meters to the right. This is my initial position right here. They move 0.75 meters to the right, okay, and then they move 3.5 meters to the left. So from here, they go 3.5 meters to the left. Okay, so my final position is here, okay, and my initial position is there. So this line actually represents my displacement. This is how far from my starting position I ended up. Okay with that idea? How do I calculate that? Yeah, subtract them. Or add them, make one of them negative. Either way will work. Okay, but yeah, if I went 0.75 meters to the right, then I'm going to subtract that from the 3.5. Okay, and I'm going to get my 2.75 meters to the left. Okay, that's all there. Okay? If that question asks what's my total distance traveled, what would it be? 4.25 meters, right? With no direction, because distance is scalar. All right. Question number three. While building a wall, a bricklayer sweeps the cement back and forth. She swings her hand back and forth a distance of 1.70 meters 4 times. Calculate the distance and displacement her hand travels during that time. Okay, so back and forth 4 times. So she goes out once and back. Out once and back. Okay, what's her displacement? 0. Okay, she started here and she ended here. I mean, I can't put those on top of each other, you can't see them. Okay, they're right on top of each other, so she ended up back where she started. What's her distance? 1.70 times 4. Right, she did 4 times. Okay, which will give us our 6.80 meters. Okay, so our distance is 6.80 meters, but the trowel ends up back where it started at the initial position, so that the total displacement is 0. Okay. Is that making sense to everybody? All right, so if we're looking at some of these questions here, obviously we've talked about 1, 2, and 3 already. Or sort of number 3. In number 3, it talks about a reference point. Well, in a lot of these questions that we've looked at, we always had our reference point. It's kind of our starting position. Okay? Without that, it's pretty hard to figure out where everything is going and how far it's gone. So the importance of a reference point is it essentially gives us position 0, okay, to work from there. Okay. All right. I want you guys to try number 4. Number 4 is going to illustrate the importance of a reference point. They want you to draw the seating plan, okay, given just this information. And it says, Chad is 2 meters left of Dolores. Ed is 4.5 meters right of Chad. Greg is 7.5 meters left of Chad. Hannah's 1 meter right of Ed. What's the displacement of a teacher who walks from Greg to Hannah? Give you a minute or two on that. Who's our reference point in this seating plan? Our reference point is Dolores. Because it says Chad like 3 times in that question, but I don't know where to put Chad unless I put Dolores somewhere. Okay, so Dolores becomes my reference point. It doesn't really matter where I put her. Okay, I'm just going to put her kind of in the middle, and then I'll draw to scale from there. So there's Dolores. Okay? It tells me that Chad is 2 meters to the left of Dolores. So there's Chad. Okay? Ed is 4.5 meters right of Chad. So how far right of Dolores is he? 2.5, right? So now I know where to put Ed. Okay? Greg is 7.5 meters left of Chad. And Hannah is 1 meter right of Ed. All right, well now I was able to put them all on there. But it was only because I used Dolores as my reference point. Okay? Had I not done that, it would have been pretty hard. So where do I put Chad? Okay. All right, so I've got this now. If I want to find the displacement of a teacher who walks from Hannah to Greg, or sorry, from Greg to Hannah, the other way, okay? It's going to be 7.5, 9.5, okay? 12, 13 meters. Right. Okay, because displacement is a vector quantity. Okay, I want you guys to try number 5. Okay, a person's displacement is 50 kilometers west. Okay, so their displacement, and I'm going to remind you of this formula here. Sorry. Okay, displacement is final position minus initial position. Okay, they're telling me the displacement is 50 kilometers west. Okay, they're looking for the final position, and my initial position is 5 kilometers east. Okay, see if you can calculate their final position. Okay, so we got to do a little bit of algebra, right, for this one. We know our formula is that the displacement is final position minus initial position. Okay, the question gives me D and initial position, so all I have to do is solve for final. So how do I move PI over to the other side? I add it. Okay, so my formula is going to be displacement plus initial position equals final position. Now, I've got east and west, which are opposites, so one of them has to be negative. West is typically negative, east is typically positive. Okay, so I'm going to have my negative 50 kilometers, okay, plus 5 kilometers equals equals my final position. So my final position is negative 45 kilometers, but I don't want to leave it that way because the question didn't give me negative, it gave me east and west. Negative represents west. Okay? So my final position is 45 kilometers west, which makes sense. Okay? I mean, if I displace myself 50 kilometers west, but started out 5 kilometers east of something else, I'm going to be 45 kilometers west of that something after I move 50 kilometers. Okay? Okay? Diagrammatically, it kind of looks like this. Okay? So let's say this is Okotoks right here. Right? And I'm starting over here, okay? 5 kilometers east of Okotoks. If I displace myself 50 kilometers to the west, I wind up over here 45 kilometers west of Okotoks. Okay? Everybody all right with that? All right, see if you can do number 6. So you got these people playing with these sealskin rackets, which PETA probably wouldn't like very much, but okay. So they're playing catch, okay, standing 3 meters apart. The child on the right, okay, so the ball is going to start here, okay, tosses the ball to the child on the left, so they toss it to this person, and then they move 5 meters to the right, so they come over here, okay, to catch the ball again. So I want you to determine 2 things. What's the total displacement of the ball and the total distance traveled by the ball. Okay, give you a couple minutes there. Okay, so what's our displacement of the ball? Remember that in this question, the ball starts here and ends over here. So what's my total displacement? 5 meters to the right. Okay? This is where it started. This is where it ended. That's 5 meters. Okay? So it's 5 meters to the right. What's the total distance traveled? 11. A lot of people want to say 8 because they look at the 3 and the 5. But remember, the ball went here and then all the way back. Right? So it went 3, 6, 11 meters. And it's easy to forget about the trip there and then the trip back. Okay? So the total distance is 11 meters, but the total displacement is 5 meters to the right. Okay. All right, and then for number 7, it's just again kind of describing positions here. Okay, describe the positions of the groom, and our bride is the reference point. So the groom is 0.5 meters to the right of the bride. Okay, the best man is 0.75 meters to the left of the bride. By the way, this is the weirdest marriage seating plan ever. Okay, because all the men sit on the right and all it's weird. But okay, and then for the maid of honor, well, the maid of honor is 1.25 meters to the right of the bride, okay, and the flower girl is 1.5 meters to the left of the bride. Okay, so just describing, making sure we have those vectors in there when we're describing position. Okay, I think we will leave it at that for today. Okay, that'll give you time to soap your desks. Okay, before you go.